Thank you for being here. My name is Luca Morgese. I work at TNO. It's a semi-public research and development company in the Netherlands. It's not-for-profit, transparent, and I'm a researcher, so I take part in many projects. And depending on the projects, I'm developer mostly, but also architect, sometimes consultant. And I'm also technical committee member in the CACAO specification, which we will present among other things today.
Yeah, so also thank you for being here. My name is Vasileios. I'm a professor at the University of Oslo, and basically I do a lot of cybersecurity with a focus on security automation and cyber threat intelligence. I'm involved in multiple European projects, and I'm also the co-chair of the first automation SIG. So if you are interested in automation and you have not joined the SIG, there is an automation SIG. We discuss a lot of things, so please join. I'm also supporting ENISA, again, in the same areas, cyber threat intelligence and automation, and I'm heavily involved in standardization. In fact, we are going to present you later on a standard for security playbooks.
Yeah. So we're actually going to start with some piece of history, taking an intermezzo from cybersecurity, because you may not know, but on this very land here in Hakata Bay, some 700 years ago, this was the theater of an attempt from the Mongolian Empire to invade Japan, not once, but twice. So the Mongolian Empire was very expert at war. It was expanding all over Asia at the time. So when it came to Japan, the first time in 1274, they brought with them some advanced weapons for the time. So like black powder bombs and some rudimentary forms of cannons as well. And they quite overwhelmed the Japanese forces. Japan had been isolated for the better part of the previous 100 years. So the Mongolian Empire really, actually through one day, overwhelmed the Japanese forces. But in the end, luckily for the Japanese, it turned out to be just a very aggressive probe. So after one day, some logistic hiccups, the Mongols retired back. So what did the Japanese do? They knew at some point they would come back. So they anticipated the threats, they adapted their defenses and built a wall all around Hakata Bay to block the Mongolian fleet from docking. So surely enough, 7 years later in 1281, the Mongolian tried again, but they were kept at bay by this wall. And effectively, the Japanese could counter this attack from the Mongols with the rains of arrows and some more targeted attacks. And this was a successful defense story. It took 53 days in the second event of this attempted invasion to counter this offensive. Now, it takes 66 days as a median time to recovery today for cybersecurity in average over different industries. Yeah, to recover from cyber attacks or counter threats. So let's do something about it. This is notions that we're all very familiar with. We have some asymmetries now in the cyber warfare landscape between attackers and defenders. In the end, attackers have as their very main business proposition that of being effective at attacking and evading techniques and creating harm or so all the incentives point towards them being very effective. Whereas on the defender side is not always the case. There are diverse incompatible systems. You have to manage people, process technologies. You have large attack surface. You have to defend everything or almost or as much as you can. All things we're very familiar with. So the industry in the last many years started adopting several technologies to make to get some margin on this asymmetry. So we have monitoring and detection, threat hunting, CTI sharing, now X-source, playbooks, but also much more. Also, we have seen at this conference. And today we're gonna focus on security playbooks. So playbooks can be defined as a series of instructions that are structured, principal processes and procedures, documented, reusable, repeatable, and optimized. And at the very essence, they tell you what to do, so what needs to happen, and when to do it, or when it needs to happen. But it would be very good, so much more effective for the cyber defenders to also know how to do it, so how to actually get to the actions that need to happen, possibly automate it to make it more effective, and to share it so that you can really share some knowledge and help the whole defenders community advance in this front. So can we do that? Well, either yes or it depends. So there are some ways in which nowadays we see playbooks, security playbooks being implemented. The most traditional way consists of documents, essentially, so emails, wikis, etc. And they tell you what to do, when to do it, how to do it, usually because they're very specific to some local realities, but it really depends if you can automate it. It really depends if you can share these things. Then, of course, you have vendor tools, great technology, great pieces of technology, what to do, when to do, of course. They know how to do those actions. They can automate it nowadays, pretty much all of them. But it really depends if you can also share all these techniques and tradecraft to other systems, to make security interoperable. And then we have some open initiatives that these are two main ones, the IACD, and then ENISA came up with guidelines on how to create playbooks, and they offer templates for security playbooks that you can base your operational procedures on, and you know what to do, when to do it, but they don't go in detail of how to do it. You can't automate schemas, not right away at least, but of course these are meant to be shared. But so all in all, we are still in this case. Now we still get this kind of statistics out of reports that we find through research. Yeah, so we need to do something still. So it would be nice for security playbooks to have some properties that realize all of these requirements that you want in playbooks. So you may want to know exactly what kind of threats some playbooks respond to, in the very details, in the very specifics of some attackers or some techniques, then you need to counter in these ways. And then it would be good if they are technology agnostic, machine readable, to make them automated and shareable by design, and so all in all, enable interoperability. So how do we get there?
So basically these requirements influenced the creation of CACAO. It stands for Collaborative Automated Course of Action Operations. And it's basically a technical specification. It's a standard, right? It's developed within OASIS, a standards development organization. And it's a standard basically that provides you with a common schema to create security playbooks. The first question that I will get, so I can answer it now, well, there are also other open standards for creating automation, right? For creating playbooks. One example is BPMN. So the difference with CACAO is that, the specification is tailored to cybersecurity operations. So it has so many properties, right? Metadata that can support cybersecurity operations. We'll see all these things later on. So technical specification, a common schema for security playbooks. As a community, we realize, that we are quite good in exchanging indicators, right, and threat context, more or less, but still we have not basically achieved a good level of maturity in exchanging defensive tradecraft, right? Some of you have seen a particular threat, you have responded, right? You are sending to me CTI, you are saying, this is how you are going to detect, but you don't tell me, most of the times, how am I going to respond? And this is also very important. A big motivation, right? So we created that so we can exchange playbooks. And most importantly, right, many of us create playbooks for standard operating procedures, right? How should we address, let's say, a ransomware? But at the same time, when you have intelligence, these playbooks can become very tailored, very detailed on the threat. So for that reason, we made sure that we can create a framework that can supplement other frameworks for cyber threat intelligence. One example is STIX, and I'll show you how we do it in a while. So this technical committee more or less comprises a lot of members. We started in 2017. We started discussing, right, the community more or less, that we need something like CACAO, right, a common schema for playbooks. Then we started partnering with different organizations, right, to have enough power, right, to create a technical committee. And we knew that this has to be a standards technical committee. We want to create a standard like STIX for cyber threat intelligence. We have gone through many iterations, right? We have published technical specifications. We have received so much feedback, and this allows us to come to version 2.0. It was released in October 2023. And basically, we consider that this is a quite stable version. And this is an opportunity for us, right? So we can present now CACAO. We feel that is quite good. Evidently, organizations have started using it, more or less. You can ask me about later. And yes, so I'll just give you an introduction to CACAO. It will be high level, still a little technical, so bear with me. So this is the high level model of the specification, right? You can imagine the specification is just a heavy document that basically identifies different objects in JSON. As we said, CACAO basically provides you with playbooks in a machine readable format. And it comprises all these different structures. So with some of the most important to be like the metadata section, the workflow steps, and agents and targets. And it's quite descriptive, right? Metadata is metadata, extra information about data. It allows you to identify playbooks, to filter playbooks, to perform queries and analytics, and also some extra stuff for the orchestration side. Workflow steps comprise the process, right? You start creating action steps, so you actually start encoding your process, and CACAO is quite flexible and comprehensive, so you'll see later on that you can apply conditional logic, right? If this happens, right, then don't do this, but do that, so it can become quite nested and complex. And agents and targets basically are elements that upon the reception of the commands, they execute them. So some examples of metadata. Basically, CACAO supports different playbook types: investigative, remediative, mitigative, attack playbooks, playbooks for threat hunting. We have something that we developed for the European Union, basically, because of a regulation. They are called notification playbooks. So we can disseminate, let's call them rapid alerts regarding threats very, very, very fast. Engagement playbooks, so request from MITRE, basically, based on how they define engagement on their MITRE Engage framework. Playbook activities, basically, this is I will say that it is a taxonomy that allows you to identify at an abstraction level what a command is going to perform. It allows you basically to read a playbook rapidly without going into the details, right? The commands per se. Playbook processing, this basically, so some metadata, as I said, they are, for filtering and querying and analytics, but we have also metadata. CACAO, now we can say that it will become the common framework for security playbooks, but, many of you will develop individual tools for executing these playbooks. And the features and the capability in each orchestrator will be different. So this property here, this metadata here will allow you basically very early on to identify if you can execute a playbook. So if I send you a playbook that implements, let's say, parallel steps, maybe your orchestrator does not have the ability to implement parallel steps. So you don't want to parse thousands of lines to see that something is going to break. Now you can know it proactively. All these things have been developed based on concrete use cases, right? We have gone through many iterations. And if it is to go a little lower, and I'm going to use the pointer now. So, and I can also see, right? So higher level, so these things here are transposed now here. And we start with a playbook, more or less. And playbooks have workflow steps. Here up, you can see the different types of playbooks. This is an open vocabulary, so it means that you can actually enrich it. The fundamental element, the fundamental construct is the action step. Basically, what the step is going to perform. And this action step connects with agents and targets, and these can be like human or organizationally oriented, or it will identify the endpoints or the solutions that you want to target. Yeah, commands, right? So actions basically include different commands. So these are the supported commands. This is just a list, so nothing special. So it means that you can start adding your own command types. As you can see, many of the known are supported. Also OpenC2, which is another basically standard, Sigma, Yara, right? Kestrel threat hunting playbooks, Jupyter notebooks, and many more. So what I like discussing the most. So, as I said earlier, as defenders, we have become quite mature in exchanging cyber threat intelligence. And I'm mostly targeting, in the context of this presentation, machine-readable cyber threat intelligence. You might have a MISP instance, you might have an OpenCTI instance, right, and using STIX, you might have another proprietary, like vendor-based solution. Okay, good in disseminating, exchanging intelligence. Not great in exchanging how we are going to respond. We created a new technical standard, right? Machine-readable format, and this standard integrates seamlessly with STIX. So I assume that many of you currently use STIX. I won't go into the details how we are basically connecting these things, but my colleague here has registered for a lightning talk, so he'll go through. He will explain basically the extension, the STIX extension that allows you to extend STIX and support playbooks. Similarly, CACAO can be extended. So when you start using, CACAO playbooks and you see, unfortunately, the structure is inadequate for me, you can extend basically CACAO, right, based on your use cases. You'll say, will it break interoperability? It might. I mean, you can forward feedback that this is an extremely important element and should be added. But I would say, the chances are very low because CACAO will allow you to basically define playbooks at different levels of abstraction. So something is going to be at a template level, right? You just describe a process. If you want to deal with automation, right, you will need to start adding infrastructure details and basically the defense components that you are going to use. You also might automate that, right? Start adding infrastructure to all these things, or you might not. So, but when you start exchanging playbooks, more or less you'll have to remove infrastructure details, the commands per se, and these would be the elements that mostly would be extended. So it should be okay. Yeah.
Okay, so beautiful. We have a really nice JSON schema to implement, to express these things. We also have on the other side, as you were saying, like many nice tools that are already quite advanced in capabilities. So how do we leverage on this? That's what we are here to show. So we can continue. We have developed two tools, one editor for CACAO playbooks and one executor. And we're going to show you this.
So the names of the open source solutions, we will have a live demo. The first one is CACAO roster. So as I said, right, we felt quite confident that the specification is at a very mature level. Then the next step, or actually the first question that I would receive in a conference, like this one is, wow, it looks great. I mean, what about support? Has anyone implemented CACAO? Do they use CACAO? Well, we actually developed open source tools for you and for us. So you can go online and you can start experimenting. You can start creating your playbooks, right? And Luca will show you also how you can execute your playbooks. Are they perfect? For sure they are not, right? I mean, they are open source projects. They are sponsored by us. Now they, at least for the CACAO roster, we have basically forwarded the IPR to Open Cybersecurity Alliance. It's still open source, but we don't have to deal with any kind of legalities. And they also host multiple open source projects, regarding CTI, automation, common information schema. So take a look at it. I mean, they are very good. Oh, CACAO Roaster, a web application. It's seamless to install it. It's containerized, as you'll shortly, but it will allow you to have a very nice user interface, right? And a drag and draw approach to start creating your CACAO playbooks, your processes basically. It's quite intuitive, so when you start dropping elements, it will start also making suggestions, not regarding the content, but what elements, can be used, in the next steps. Of course, the objective is right, embrace adoption of open source, vendor agnostic, standard-based efforts. And we want to use it. We had requests from the community, right? How can we use CACAO? So this was the motivation. Multiple features, from digitally signing playbooks and counter-signing playbooks, if you want, right? Company A can sign playbooks. Company B receive a playbook. They're saying, wow, this is a very good playbook, right? And we confirm that. They can counter-sign the playbook, okay? And using the roster, you can also then verify the signatures. Well, you can export playbooks in using the STIX 2.1 extension that we have created. The metadata section will have all the metadata that you can enrich your playbooks. And I think I have a slide for that. I have more details here. We have also implemented like a common schema, a common coordinates schema. We call this layout extension, and this is like a work product now in OASIS. And basically, you have now a common way to add coordinates to your workflows, right? Because it was a concern that, yes, I can exchange a JSON file with you with a process, but the visualization of it is so important, right? In terms of readability and understandability, right? So you don't want to get a playbook and then when you load it, it will just be one straight line. It's just crazy. So we'll create a common way. So when you implement CACAO, if you create any tool, you can use many of these technical specifications. So for harmonization, more or less, for the sake of interoperability. JSON validation schemas, open source, right? You can go online and you can use them. I think you use these JSON validation schemas as well. Yeah, and most importantly, right, the application is very modular in terms of coding. So you can take pieces of it and you can create other applications. So we have, for example, a specific library for creating CACAO objects, right? The JSON objects themselves. So this is something independent of the user interface that you see. So you create another application, you can reuse code. Just for your eyes, right? I mean, the technologies that are used for the roster. The only thing that I will say is that it's mostly written in TypeScript. And we have a release, so we kept this one for first one, later today or tomorrow, based on the schedule. But the new release basically supports integrations. And in particular, we have now one integration with their tool. They have developed the execution engine, basically, an execution engine and the execution engine of CACAO. Yeah, and just to show you that, upcoming releases have been already scheduled. The project is on GitHub. We have a Slack channel as well, right? We have a community, so you can come there and ask questions. Feedback is, the most welcome thing. Well, we need your help, right? If it is to make it better, support the project. I think it will be, just experience it and let me know, okay?
All right, so a few words about Sorka tool. Again, some technologies, stacks we operate with, supported on major operative systems. We have an SBOM of it, it goes on Docker, and it's developed in Go land mostly. This is the core idea of Sorka. So the two main pillars is that it's completely open source, free and adaptable, and it's based on open standards. And this comes from our own research needs, but we wanted to develop some robust products to, do also some research in security interoperability. So we follow the standards and we have created this tool, which really in 2 words just ingests CACAO playbooks and then executes them based on the steps. And it can be used for defensive operations, but also offensive and also self-healing, and we are researching on this. A couple words on the technical functionalities. This is the original architecture of SORCA. It's been expanded as we speak. So it decomposes a playbook. It's quite modular, so we can build on top of the software quite easily. And we have all what we need to make it nice and usable. So a database to manage playbooks, a logging framework to record all the actions of the executions. And then we can add extensions, which we call fin, because SORCA is like an orca. So those are the extensions. And yeah, I'll spend a couple more words on fins later too. And we are also planning, like we are in current development process, and we are planning some next release. The SORCA 1.1 it's practically ready, will come up in I think matter of a few weeks. And we are already providing APIs for integrating it with third-party tools, so pool-based APIs on the execution. We already have a Python library that you can build eventually extensions to run your own protocols if you need it. And we will implement connectors to some major source SIEM tools, and yeah, anything else that really research brings us towards. And a couple words on use cases. So this specification and these technologies we are currently employing mainly in 3 European research projects: AI Inception on empowering the cyber defense operations with AI, efforts on making energy grids in Europe more resilient, both on the cyber side and processes, physical side. And Phoenix 2, which is
Nevertheless, we have links here, and we are almost out of time, so we'll take a couple of minutes to demo the tool. I mean,
you can look
slides
this
will be
up.
publicly available, so you can get more details, right? How we have implemented CACAO in these projects.
Yeah, so it's demo time. For those who followed Lucky Leaks presentation, we didn't sacrifice a calculator, so let's hope it works. So this is just what you're gonna see in the demo. We have it's all Dockerized, so it's a sample environment, but we have a LAN with one device that is vulnerable to a backdoor. It's a web shell, and there's a command control IP from an attacker on the internet. And then we get the information on some CTI platform that we have a hash of a malicious executable and an IP address, in this case, that we need to block. So following the IACD guidelines, we have developed a playbook that retrieves the IP address, blocks it in the firewall rules, and then notifies. In these cases, we have a Slack bot that we can use as a simulation of a case management system. So this is what's going to happen. And we also have to deal with the hash, and we will retrieve the hash again from the CTI platform. We will trigger a search and destroy script to find if we have this executable running in some of our machines, and destroy the process or block the process, and then notify again Slack. So let's hope it works. So in these 2 terminals, we have here on the left the web shell, and this is the attacker. And we see if we run a wget, it's usually a bit laggy, but should eventually work. Yeah, so you get the, this is the front page, but you can also run some shell, like terminal commands on it. In this case, it will list, all the contents of the root directory. So this is clearly something you don't want. And these are the rules of the firewall. So we see at the moment it allows all traffic. So here we have, it's a bit split, but this is the view of the CACAO roster. So we have developed this playbook. This is what we just showed. And we can execute this playbook. And in a few seconds, we will see the logs on this side and hopefully receive the messages on Slack. Let's see. Yeah, there you go. Perfect. So as you saw, all these steps executed automatically. And now we also receive this notification. So we block the IP, we found a process, executable process with this hash, and it was removed. And if we go back here, we list the firewall rule, we will see that we have the firewall rules. And on this side, well, it was slow before, but I can assure it doesn't work. Also on this side, we were able before to ping the command and control IP, and now we can't. So it's just blocked by the rules. Okay, and this demo, so this is representative, but it can integrate really via HTTP API with any technology. We actually developed the same demo, but with OpenStack. No, yeah, with OpenCTI and OpenSense firewall, it's all open. Yeah, so this is an example of the kind of things you can do. So next steps, as I said, Sorka is being developed in our research company. So we're going to continue develop it as long as research brings us forward, but we do plan to keep supporting it for the foreseeable future. And also promoting, yeah, CACAO adoption and the tool adoption. But the main important message, I think that the one takeout is that this is all free to use. And we really invite you to just download it and play with it. We also have examples that you can run. And yeah, you can just use it and see how you find it. And yeah, maybe try to integrate it with some functionalities and have fun with it.
Yeah, and for the roster, as I said, I mean, we keep adding new features and fixing multiple bugs. And we need your support, so start using it. If you want to contribute code, please do. If you believe that you'd like something to be added, open an issue, right? We'll answer back as soon as possible. Yeah, this is it from us, I think.
Yeah.
So thank you very much for attending. And I'm not sure if we have time for questions.
3 minutes.